For the first speaker of keynote speech part 2, we will hear about Clearwire's vision and plans around WiMAX. And ladies and gentlemen, please welcome Mr. Ali Tabasi, SVP Global Ecosystem and Standards of Clearwire USA.
Good morning. As distinguished guests, I don't know what I said that a lot of people left the room, so maybe through more presentation they can come back. But I thought picture is better than 1,000 words, so I have a lot of videos that I'm going to share with you and also share the vision of WiMAX within Clearwire. Sound?
Ask not what your country can do for you. Ask what you can do for your country.
It's one small step for man, one giant leap for mankind.
But people have got to know whether or not their president is a crook. Well, I'm not a crook. Mr. Gorbachev, tear down this wall. My mom always said, laugh about the chocolates.
Again, good morning. As the video suggested here, that we are in the age of transformation. You know, the early days that we had the mainframe computing and computers were sitting in a room somewhere is changing. And as Ron tried to explain it, we are mobilizing internet, and we are having the internet available to us at any devices, anytime, any location that you're going. Let me share with you what has happened in the United States, and I'm certain similar capabilities has occurred in other countries. If you look at the chart on the left, is what has happened into the voice utilization in the United States in the last 15 years. The total minutes of use by the voice has increased over 300%. And the tipping point occurred more on the wireless side than the wire side when we had the right amount of coverage in place and the right pricing in place for the end users, that they were able to use their devices wherever they were at the right price. Of course, we still have to take care of the roaming issues, but that's a different challenge that we have to discuss. On the chart on the right-hand side, you can see as more and more end users were able to connect to the internet and being able to have access to their data and information and entertainment, the total utilization has been growing rapidly on the fixed environment. For a moment, imagine the same thing happens as we mobilize internet and create wireless capability everywhere, anytime, any device for internet. The growth is going to be huge, and that was one of the genesis behind why Clearwire and Sprint went after mobile broadband in the United States. What does that mean when you say that increase? I think you saw a slide from Ron by McKinsey. World Bank did a study recently that for every 10% increase in internet broadband connectivity, the GDP of the country increases about 1.3%. In a developing countries, they're expecting that be a lot higher than 1.3%. What does that mean? This is not just for developing countries, also for developed country. If you look at it, the study that was done by CTIA, in US alone, 1% increase in broadband penetration has corresponded to $2,000 increase in per capita of GDP. And lastly, by Brookings Institute recently, as you all know, President Obama in the United States have been very much behind the deployment of broadband to the rural areas and have this stimulus package that is working out. The study that was done by Brookings Institute is that for each percentage point increase in broadband connectivity, it creates close to 300,000 jobs in private and public industries. This is all about growth, all about innovation, and all about better style of life and everything else that's going on. I think Ron briefly mentioned about the capacity requirement. Let me give you a little bit from an operator point of view, the steps that we are going through and why none of the existing technologies has capability of meeting the broadband, the capacity demand that the end users are demanding with existing technologies, and why there is a need for a mobile broadband capability. If you remember the simple handheld devices that we have had for call, SMS, and very narrowband data connectivity, on average we were utilizing about 30 meg per month connectivity on a data. With the influence of smartphones, and especially iPhone, and a lot of people talk about iPhone as an iconic device, that utilization has been grown 30 times more. And there's not a day goes by that someone in the United States doesn't complain about the capacity of the operator in the United States that is offering iPhone is not there to meet the demand of what they want from the device that they are utilizing. When you go to the more mobile computing and mobile internet devices, that utilization is 450 times more than the simple handheld device. What does that mean? In the past, we had about 30 meg per month. With the advent of the smartphones, that's about 1 gig per month utilization. And very soon, with all the utilization that is going on with the mobile computing, mobile internet devices, and smartphones and others, that's about 15 gig per month average utilization. Ron mentioned about the Yota's experience in Russia, that they are experiencing about 10 gig per month utilization. And we are experiencing in the United States an average of 8 to 10 gig per month per user utilization. None of the existing technologies, 3G, 2G, 1G, 2.5G, can afford having this type of utilization on their network. Not to mention they were not designed to have this type of capacity at the same time that the utilization of growth continues to grow. Some of you may say, how would someone get to 15 gig or 10 gig per month? And here are some of the examples that we have experienced in our network in the United States that you can see very easily with few hours per day of downloading emails and connecting to the social networks, doing some media broadcasting and downloading medias and others, you would reach the 15 gig very easily. It is not out of this world, is not futuristic, it is here today, and a lot of users are experiencing and utilizing the network as such. Here's what I said. There's not a day goes by that someone is not complaining about the capacity challenges of 3G networks, be it HSPA or EVDO in US or outside of the United States. So how do we have to solve the capacity crunch? Number one, we need to have the right amount of spectrum and be able to deliver broadband technologies in a good experience to the end users. In the United States, we have an average of 120 megahertz of spectrum nationwide that is dedicated for this application. True, we are unique. Our friend in Latin America, Brazil, Venezuela, and Mexico can experience the same thing. Of course, if some of the political things can get resolved. But other than that, you need to have the right amount of spectrum to offer. Coming up with a 20 megahertz of spectrum on a reuse of 1, you're not going to be able to offer any good user experience, regardless of what technology you're going to use. So let's be clear on that and what is important to have the right amount of spectrum available to deliver the right experience to end users. Next, you need to have the right technologies. None of the existing technologies on the GSM side, on 3GPP or 3GPP2, be it GSM, TDMA, be it CDMA, is going to meet that demand. So we need to move to a more robust technology that takes advantage of broadband channels and deliver a more robust experience at the wider channels and higher throughput. So OFDMA is the right spectrum, right technology to be utilized for that capability. We need to move to more an all IP network and create a simpler IP technologies and network to be able to introduce the application and services faster and lower the cost of deployment and lower the cost of development at the same time. And lastly, have a lot of devices available that they can automatically recognize the network and attach to the network, be it as an add-on or be it as an embedded devices that they can connect to the network and change even some of the model that exists today on a subsidy. So more and more you will see that more consumer electronics and embedded devices, mobile computing and others becoming available because of the path that WiMAX is taking, which was similar to taking the same path of Wi-Fi. As Ron mentioned, there's a single chip that does Wi-Fi and WiMAX. So very soon, a lot of devices that they have been doing Wi-Fi connectivity at the same price of, hopefully, the chipset or module of Wi-Fi, they can have both Wi-Fi and WiMAX available and embedded into the devices. As I mentioned, in the United States, we are unique. We have about 120 megahertz of spectrum, and what that means is in some markets we have a lot more than 120 megahertz. In some markets we have a little bit less than 120, but on average we have 120 megahertz of spectrum, and that has afforded us to go to market with a reuse of 3 or reuse of 6. As a matter of fact, we started the early days with the reuse of 3, using 30 megahertz to launch the market. But in the recent markets that we have launched, and also because of the overwhelming acceptance by our customers and take rate by our customers, we were very glad that we were able to have additional spectrum and increase our capacity by adding additional capacity, additional channels to the existing sites, and also rolling out new markets with 60 megahertz of spectrum. That's unheard of. This is, again, we are using TDD technology overall our nation. Bless you. What does it mean, more capacity, more spectrum? Again, a lot of people have a challenge to put 2 and 2 together. So I have a little bit chart here. Regardless of technology, WiMAX, LTE, regardless of you using 700 or 2.5 gigahertz spectrum, 120 megahertz of spectrum is a lot of spectrum. We can have a lot of capacity and a lot of capability with that than 40 megahertz or 20 megahertz or even 10 megahertz. So I know there has been a lot of discussion, and again, I'm an engineer by heart, so I cannot draw anything without talking or talk without drawing anything. So I put this chart together to put this nonsense that's going on. Is WiMAX a 3G or 4G technology to bed once and for all? When you look at the radio access technology evolution, we went from the analog technology to digital, US TDMA or European GSM technology, to improve the capacity of our voice network and improve our battery life. We moved from 2G technology to 3G technologies that they will either CDMA 2000 or wideband CDMA. The 4th generation of radio access technology is an OFDMA technology. You don't have, you can't go from a CDMA to OFDMA on the same channel. You need to build another network to do that. And I congratulate Taiwan as a whole and ministers and others to see that view and offer that capability to the operators here to go to market faster with the time to market advantage that exists. Here's from a standards point of view. Regardless, you're a 3GPP or 3GPP2, you're hitting a brick wall with your existing technologies. Your 3G is either EVDO Rev A or Rev B, which is multi-carrier Rev A, or wideband CDMA, HSPA or HSPA Plus. After that, you need to build another network that supports the next generation OFDMA technologies. WiMAX started with the knowledge of OFDMA, start from a fixed capability and moved on to the mobility very rapidly. WiMAX has a time to market advantage, at least 2 or 3 years, be it from a technology, from their WiMAX, as Ron mentioned, their WiMAX commercial today versus others, the competing technologies that are still in the laboratories and testing environment. Regardless of which technology you look at or which name of the technologies you look at, they have certain things in common. They're OFDMA-based technology. They are trying to take advantage of all IP network. They're taking advantage of the advanced antenna systems, be it for MIMO or beamforming. And also, they're looking for a broader band channel, lower latency, and higher throughput capabilities. Again, advantage of WiMAX, time to market, and also the Open Patent Alliance that Ron mentioned that has been working for the last 3 years, and finally things are moving along and having the patent pool happening as we speak. The benefit of WiMAX is not just the technological advantage and time to market advantage of it, but also the capability of transforming the existing business model that exists in the cellular and telecom operators. Again, we brought that challenge to ourselves, and we see WiMAX be the ways for us to overcome that. For those of you that recall, you guys remember those brick phones and Cuban cigars as our handheld devices that we had? Those things were costing over $1,000 thanks to our friends from Motorola and others that they kept developing those for us. But in order for an end user to be able to use those, what did an operator do? Bought that at $1,000 or more, subsidized for it, and sold it to the end user at the reduced cost, about $400 or $500. In order for an operator to recoup that subsidy, what do we have to do? Get a contract from end user. In order to get a contract, we need to make sure that the end user is creditworthy. So we have to do a credit check. So we end up sending away a lot of customers because they didn't have a good credit, but they were cash customers. Why couldn't we take the cash customers? Because we had to have a contract, 2-year contract. WiMAX overcomes that. When these things are embedded and are available or at the low cost, you know, we are in the United States, our USB dongle is below $60 US. Below 60 US. Our friends in 3G environment, they are paying $190 US or higher. The difference today between a WiMAX USB dongle and a 3G is $130 or more. What does that mean? I don't have to pay that much more money to capture a customer. Because the cost is so low, the customer is buying that device. I don't have to subsidize for it. And because the customer is buying that device, I don't have to have a contract with that customer. Transformation of the existing model. That's the value proposition of WiMAX, that no other technology today or tomorrow can touch it. LTE, because of their backward compatibility requirement that they have with 3G and 2G, they will never be able to get the same pricing on the chipsets or modules or devices. So, everything I've said to you has been, you've heard about it either in the news or standards or discussions. But let me share with you what we have seen in our market rollouts in the United States. In Portland, we took a route and tried to make sure that we do a drive test, both cover all different areas, be it the residential, be it the commercial, be it the downtown or rural areas, and drive on a 55, 60 miles per hour and compare our network performance to the other three operators that they were there on an EVDO Rev A, operator 1 and 2, and also HSPA, operator 3. So what we have seen is what's in front of you. We, on a peak throughput, what we experience in the field with our USB dongle or embedded laptop was about 19 meg on a downlink. And the challenge was not because of the technology, the challenge was the processing power of the device could not go higher than that. The technology can afford a lot more than that. And our friend from Portugal is taking a picture of it so he can go show it to his friends back in European Union and see what they are seeing there. But on average, our customers are experiencing in a mobility anywhere from 4 to 6 meg downlink on a 60 miles per hour or more driving. On a stationary, they're experiencing 6 to 8 megs on a downlink. On the uplink, in a mobility, you can see anywhere from 1 to 1.5 meg on an uplink and about 2 meg on a stationary. No other technologies today is available to offer that type of service. And of course, having the right amount of spectrum helps you with that too. So let's listen to some of our customers that they've been experiencing our network and what they are saying about it.
Oh, it's already connected. It's pretty fast.
Definitely increased my productivity. I was able to download large PowerPoint presentations, check my email, and stream video, everything that I pretty much wanted to do. It's definitely faster than my DSL I have at home.
I'll be able to go outside, nice sunny day, and study, whereas before I would have to sit inside.
And the download is complete. My assignment downloaded faster than it would have if I was on the school's Wi-Fi.
A lot of places where I never expect to even be using WiMAX, it worked great.
Bandwidth has been quite good, especially while in motion.
I can get broadband speeds without having to hook up to Wi-Fi or anything like that. I just open my laptop and I'm ready to surf.
At the tone, please record your message.
It's Toby. I'm calling you from Patterson Park via WiMAX connection.
It's pretty equivalent to my home computer that's actually plugged in.
So I'm on Hulu. I want to check out this Saturday Night Live skit that somebody told me about that I missed. I'm actually in between a couple of big buildings right now. No delay whatsoever. No delay.
Before I play the next video, let me share with you again. In Portland was one of our market that we launched January of this year under new brand Clear. And the reason everyone is going outside, and some of you guys have been in Portland, the weather in Portland is not that great that for people to be outside all the time. So whenever the weather is nice, everyone wants to go out. That's another reason that they wanted to have the capability outside, not to mention the weather, cold or rainy and other stuff. Sometimes people like to go outside to do that. But at the same time, iPhone has gone through several generations. They came up with their 2G devices, didn't do well. They came up with their 3G devices, still didn't do well. Then they came up with the 3GS, and I don't know what does S stand for. But what they try to do is to improve the experience of the end user, not because the capability of the HSPA was good, but they were trying to do something in the network and on the device to make things happen or load up faster and create a better experience. So we did we hired a company to do a comparison of the iPhone 3GS versus an iPhone 3GS connecting to a Wi-Fi using WiMAX as a backhaul for it. So we have a public, personal hotspot that we use in the United States, which uses Wi-Fi as a backhaul and, WiMAX as a backhaul and Wi-Fi as an access. So you can connect up to 5 devices to this personal router that you're utilizing. So we did this trial, just again, remember, a an iPhone 3GS that is connecting via Wi-Fi to our personal router, and that personal router connects to the WiMAX is one model that I'm going to show to you, and versus using iPhone 3GS connecting to the AT&T network. think you get the view there, but just imagine if the device was directly connected to WiMAX rather than going through Wi-Fi and then transition to WiMAX, how much faster the load time and others could have been. So there's a little bit delay between going from a Wi-Fi to WiMAX versus the other one that was using. So again, this was done for answering some of the question about is WiMAX competitor to HSPA. Well, as you can see here, HSPA is not even coming close to be a competitor to WiMAX. I think Ron mentioned, and I need to correct my slide, Ron mentioned that there will be about 300 devices certified, and I'm certain majority of it is coming from Taiwan. Please make it happen more and more. I'll love to see more of those available in the marketplace. But again, when you come up with the new devices, you have to wait for the end users to go ahead and get these devices, purchase it and other stuff. But so what we came up with, our first generation of personal hotspot was, or personal router was to take advantage of anything existing with the Wi-Fi can connect to that. And there's a video, but I'm going to skip through that since you already saw the comparison video right there. Lastly, it's not just about device network, all IP and the technology, but also we have to have the right applications in place. In September, we launched an innovation network in Silicon Valley that covers the campuses of Cisco, Google, Intel, and also Stanford University. And we have opened it up in the 4G developer for companies to come in and develop applications for a broadband network. And our team, our team's been working with Skylink here to develop more and more applications and devices available for connectivity here. And I'm pleased to see where it's going on. And I think we're going to do a tuning of same thing in Malaysia very soon with MCMC and others. I think it's going to be announced next month. So more and more applications going to be developed that does not exist today. That doesn't mean any of the existing application cannot have a better experience on a WiMAX network, but there will be newer application coming to play. In the United States, we will be deploying WiMAX nationwide, and our goal is by the end of 2010 cover 120 million population and continue growing after that. Some of the markets that have been identified to be launched in 2009 and 2010 is identified in the chart behind me, and a month does not go that we have not launched 1 or 2 or 3 networks up and running. Let me skip over that. This is an identical slide to what Ron mentioned, but in general, again, WiMAX is worldwide. It's not just in one country or others, and it continues to grow more than that. Let me end my presentation with 2 specific notes. Pure Internet, one of the research firms have come up with that by 2020, the mobile devices will be the main application, main device for the end users to connect to the internet. And in CES this year, the CEO of Sony identified that by 2011, 90% of the Sony devices will be connected to each other or to the internet and continues to grow. So this is the wave of more consumer electronics and more embedded devices to become available, and WiMAX is the unique technology that can make that happen at the low cost. Thank you very much.
Thank you, Mr. Tabasi. Next, we are going to hear about new stage of wireless broadband, and the next keynote speech is delivered by Mr. Masanori Narita, Vice President from UQ Communications, Japan. Ladies and gentlemen, please welcome Mr. Arita.
Ladies and gentlemen, let me first congratulate for the opening of the WiMAX Summit Taiwan today. I'm very much honored to have this opportunity to speak as the sole Japanese WiMAX operator. I respect Taiwan and Taiwan government that they have been leading Taiwan and WiMAX as a key technology of wireless broadband. Today, I would like to mention about our open business model and our policy and current situation of WiMAX in Japan and direction as the social infrastructure. Telephone and fax, cellular, PC, internet, and so on. ICT made our daily life enriched. 10 years ago, nobody could suppose such rich ICT world. Current PC's memory size became bigger and bigger in its smaller and smaller body. What is next? Paper has been main media to record or communicate for a long time. And floppy disk or CD, DVD emerged, but they are used in local use. But currently, the internet changed it. People use internet by downloading anything from internet site. From now on, as you know, new cloud computing is a bigger trend of ICT. At the cloud computing stage, everything will be in internet or in network. It will make great innovation in business and personal life too. In this stage, WiMAX will be essential because of its high speed and economical internet infrastructure. How is a home appliance? TV set, video camera, refrigerator, laundry machines, etc. But currently, a home appliance is standalone. But they will be networking each other. They will change to merge to smart systems. Current environmental demand will push this trend. High-speed internet. As Ari-san said, current high-speed internet is connected by fixed line, but mobility is little. But near future, it will be changed by WiMAX and mobile PC. People can use internet anywhere. So to realize them, we need various network devices and low-cost infrastructure and participation of many industries. In ICT area, there are two business models. One is a vertical integrated model. Another is open model. Cellular or 3G is vertical model. This model, 3G carrier manage all services, contents, and handset, and so on. Services restricted by 3G carriers. But in open model, it's different. Typical example is internet. In the open model, many players work in each business area and form broad and deep business field each other. Internet really showed it. UQ promotes this open model. It's quite different from cellular or 3G business model. UQ's policy is as follows: open network and open device. We promote MVNO, mobile virtual network operator, and develop retail device market. We believe WiMAX ecosystem will bring mutual benefit for all. Then let me introduce our UQ WiMAX. UQ Communications is the sole operator in Japan, founded 2 years ago. We got the license of 2.5 gigahertz band for nationwide in Japan. It was awarded in December. We have 30 megahertz bandwidth, smaller than the United States, but we installed many WiMAX base stations. First base station was completed in August last year, and we launched a pilot service in February this year. Hearing from the monitor's comment, we launched commercial service in July. Currently, our service area is Tokyo metropolitan area, and Nagoya, and Kyoto, Osaka, and Kobe, big cities in Japan. And our plan is by the end of fiscal year 2012, we want to cover more than 90% population. And this chart is our expansion plan. Now our coverage itself is 10% and more, but by next March we will cover 55%, including Sapporo or Sendai, Hiroshima, and Fukuoka, and so on. In Tokyo, we already covered downtown Tokyo. So when you come to Tokyo, you can enjoy WiMAX freely. Oh, sorry. We have CTEC Japan, one of the biggest ICT show in Japan in October. 3 weeks ago, we had a small booth in that show, and UQ WiMAX fascinated many CTEC visitors. You may know Akihabara, electric town in Tokyo, and we often make a UQ WiMAX event at Akihabara. This was our trial event in Akihabara Station. Then let me show our tariff or price plan. Our main service tariff is UQ flat. We say UQ flat, completely flat rate, almost $50 per month. We have no restriction for the terms. Cellular companies often make a 2-year contract or so, but we don't have such restriction. near future, we need non-PC tariff will be needed. And it's a sort of characteristics of UQ WiMAX plan. We have UQ Wi-Fi option in it. For UQ customer, it's free. And our Shinkansen between Tokyo and Osaka has Wi-Fi service. Central JR Railway make using train radio, they offer the Wi-Fi service in train. So we use these facilities. We cover Tokaido Shinkansen bullet train and Narita Express, etc. and the airport. They have already Wi-Fi base stations, so we use Wi-Fi option, not only WiMAX. And PC is now Windows 7 and many innovations. So we have multi-device option, second device or third device, etc. But we have one session, non-concurrent multi-device. We offer only $2, around $2 per month. Very, very small at fare. Then we would like to expand second PC or third MIDs and so on. Next, I would like to refer a WiMAX embedded device. WiMAX embedded PC, we say WiMAX PC will become popular following Wi-Fi. It is easy to sign up. In this open world, it is important for customers to subscribe easily. It's an example of WiMAX embedded PC, and the customer can easily subscribe and use internet at the same time. In June, many PC manufacturers in Japan announced to embed WiMAX mobile WiMAX module to new PCs. Many directors of manufacturers has a press announcement. And next stage, MID, the mobile internet device, will become popular, and we would like to embed it too. And car navigation is interesting. WiMAX embedded car navigation will change our car life. In the initial stage, we started from data card, and now we started WiMAX PC, the yellow stage. But from now on, we would like to make a new market, non-PC area, for example, home appliance and machine-to-machine area. And we seek to be social infrastructure. Let me introduce an example as a social infrastructure. UQ support internet service in Narita Express, Airport Express train in Tokyo. Narita Airport is #1 international airport in Japan, but it's far from Tokyo, as you know. Narita Express is a very, very popular airport express. They connect Tokyo and Narita, not only Tokyo and Narita Airport, but Yokohama and suburban cities directly. We already installed our base stations along this railway, and from this October, passengers can enjoy internet in new Narita Express train. It's a new rolling stock. When you visit Japan, please try and enjoy WiMAX, including Wi-Fi too. And next one is WiMAX Wi-Fi combined service, as I referred. Our WiMAX area is Tokyo metropolitan area and Nagoya and Osaka, and Shinkansen direct train connect each other. And the new train has a Wi-Fi service. So we combine these, and you could provide seamless internet connection between Tokyo and Osaka. It's a sample of infrastructure, but additionally, we already started to provide the data transmission for convenience store, railway convenience store in Tokyo. Some stores has WiMAX and make post data and also. It's a trial version, but no problem. So we would like to expand these usage. As a conclusion, we would like to refer to future evolution. Today, WiMAX is super fast, but we just started service, so coverage is very, very little. But near future, we would like to expand our service area to nationwide in several years. So coverage will have no problem. And next one, as Alison said, we will make a new version, 16M. So super fast in it. In this stage, people take mobile broadband for granted. Society is go to the next stage. The conclusion is as follows. We promote real wireless broadband service, and we create WiMAX ecosystem with partners. Wide range and many industries' participation will be important. And you could develop WiMAX market and contribute WiMAX industry, collaborating with WiMAX operators in the world. Taiwan is the center of WiMAX business and WiMAX industry, and WiMAX Forum will play a more important from now on, and UQ will cooperate with you and make a new WiMAX world together. Thank you very much.
Thank you, Mr. Arida. Now we are going to hear from the last keynote speaker for this morning. Ladies and gentlemen, please welcome Mr. Roger Marks, Vice President of Technology Standards, WiMAX Forum.
Talks before I got on, some very exciting things happening with the operators throughout the globe. I've seen that through a few different events, and not only the speakers here today, but if you get a chance, you should try dropping by the exhibition that's happening a few blocks from here, because I was over there yesterday taking a peek, and it's really exciting to see what's happening, particularly here in Taiwan, that's really helping to drive the industry forward in a lot of these areas. Arita-san mentioned at the end of his talk the directions on how to go take WiMAX from super fast to super fast, and how that's going to be happening in the future. And this is an issue that I'd like to address in some remarks today, focusing on how WiMAX Release 2 is going to make sure that WiMAX provides a long-term future for growth of technology to support the requirements that are continued to develop. As our president of the WiMAX Forum, Ron Resnick, mentioned earlier, it's really critical that we make sure that WiMAX is future-proof, and it is future-proof. We have a really practical, functional, and very, very impressive technology in WiMAX Release 1, but we're moving forward to lay the groundwork for WiMAX Release 2 that will offer lots of new potential, new features, and new functions. The core of the technology is a decision that the WiMAX Forum made to support a Release 2 based on the underlying technology being developed in the IEEE 802.16 working group. The amendment being developed in that standards group is the 802.16m. And what I'd like to just overview in this talk is a little bit about the 802.16m activity and the project, and where it's going within the ITU and the IMT Advanced. So this is a little bit of a dry topic in a sense that it's standards oriented and it's not as exciting. There are no videos yet, and I haven't really worked this through the marketing department to get really exciting pictures, but I think that the fundamental issues should be of interest to you, and let you know where things are going. So essentially, I'd like to talk about the IEEE 802.16 working group, the standard that it has developed and the new standards it's developing, and how this is being developed through the International Telecommunications Union for IMT Advanced purposes. Now, some of the slides are a little, a lot of the slides were developed by the IEEE 802.16 working group, and I presented them about a week ago in Dresden, Germany, at the third workshop on IMT Advanced. And at that time, the initial proposals were made for IMT Advanced purposes as proposed technologies, and the IEEE was one of two technology proposals that was put forward to IMT Advanced. The other one came from the 3GPP community. So IEEE 802.16 is really at least two different things. One is the working group on broadband wireless access that develops and maintains the standards. And it's also the designation for the standard itself, which is a book that you can get from IEEE, which is the air interface for broadband wireless access systems. I happen to be chair of the 802.16 working group, and I've been the chair for over 10 years now. The activity was formalized in 1999. It meets at least 6 times a month, so it's a very active project, and I have some data just to try to show you here the breadth and the detail in which this work is being done. We're about to hold our 64th session, and in fact, last month we had 63 and a half, so we've had more than 64 sessions. It's an open process, and anybody can participate. I see a lot of our participants are in the room right now. People become members simply by coming to sessions, and we currently have 437 members from throughout the world. I made a chart to show give you an idea where we meet and who comes, and you can see that we meet many places throughout the world, and our attendance sometimes runs over 400 people. We met in September in Korea with a little over 250. We're part of the IEEE 802 Landman Standards Committee, which develops a whole series of standards for networks, and really is the dominant group for developing standards for data networks, and has been for over 25 years. At the moment, this just shows you the different working groups in 802 and the attendance over the last at the last session, and you can see that 802.16 is the largest group in 802. The second biggest is the 802.11 group that develops the Wi-Fi standards. 802.15 is next, which develops standards for personal area networks. And then the fourth on the list is 802.3, which is responsible for the Ethernet standards. So this is really the heart and core of where computer network standards have been developed for the last few decades. And this is the place where we chose to develop, years ago, the standards for broadband wireless access, as distinct from working through the telecommunications community for standardization, because for developing standards for wireless internet, it seemed to us that the natural environment to come from is the data communications background, and that's where we work. That's the culture and background we work from. The standard, as I said, has been developing for a number of years. As you can see, the first standard we completed was in 2001, so we have a tradition of evolving the standard rapidly, but we've been through significant development. We first introduced OFDM and OFDMA technology in the 802.16a standard in 2003. So there's no question that we have a long tradition in the OFDM, and we were the first major broadband wireless access standard to introduce OFDMA, which goes back now for over 6 years that we've had it available. So this is really, if you look at what's happening in 4G and what will be happening in IMT Advanced, there's no question that 4G is about OFDMA and the MIMO technologies as their core. And 802.16 is the group that pioneered this activity and has worked on making sure that it's technically practical and functional. So we've developed through several rounds. In 2005, we introduced the 802.16e standard for to provide full mobility. And earlier this year, we finished a new version of the standard, 802.16 2009. And also introduced the 802.16j standard for multi-hop relay. Now, the 802.16m project was initiated in 2006, and it was the first standardization activity to target IMT Advanced. It goes back really, this is 3 years ago now. And the 802.16 working group initiated this activity specifically to make an advanced air interface that would meet the IMT Advanced requirements. At the time, the IMT Advanced requirements were not even yet defined, but the working group began to develop its own requirements that it anticipated would be aligned with IMT Advanced, and as time went along, it adjusted those technical requirements to align with the ITU's requirements. A critical aspect of the project, as defined from the beginning, was to provide full legacy support, and it's a very tight requirements on backward compatibility. The new advanced 802.16m base station will support the legacy mobile stations at the same performance that the legacy base station could provide. And the 802.16m mobile station will work with the legacy base station with the same performance that the legacy mobile station would provide. And we're also supporting handover of a device from the legacy base station to the new one. So there's a great opportunity for operators to be evolving their networks and introducing new devices while supporting their existing deployed infrastructure and mobiles. As 802.16n is developed, it's important to understand the kind of community and ecosystem that's behind this activity. The work over the time, I believe there's been 17 meetings that the working group has had since the 16M project began. This has involved over 1,200 professionals from about 240 organizations in 23 countries. And another way to judge the amount of activity going on inside this project is to look at the technical documents that have been contributed to the working group toward the development of the standard. Since it's begun, there have been over 4,000 technical documents submitted for consideration in the working group. This year alone, it's been over 2,200, and there's still one more working group meeting yet to come. The activity in the working group was actually considerably more formalized than it had been in past occasions. Because of the engagement with ITU, it was felt that it was important to start with a very high-level approach, beginning with a formal process of an evaluation methodology, and then a stage 1 and stage 2 documents. The stage 1 is called the system requirements document that defines the high-level system requirements. The development of this goes way back to early 2007, and the current version was just completed in September. So the document has been updated and fine-tuned and maintained as time goes along. This formed the basis, this system requirements document, stage 2, formed the basis of the proposal to the ITU for the IMT advanced proposal, because it described the high-level view of the system that could be then evaluated. Well, so let me, hang on a second. System requirements is still a stage 1. The system description document is been developed since 2008, right? And this is the this was also submitted to the ITU. Some of the topics that are under development in the SDD, or the system description document, are the basic ones you'd expect of any radio interface technology. But in addition, we're providing explicit support at the lower 2 network layers for location-based services, an enhanced multicast broadcast service, multi-hop relay, femto base stations, self-organizing networks, multi-carrier operation, interference mitigation, and inter-base station synchronization. The ultimate output of the working group on this project is the so-called stage 3 document, which is the actual standard with the detailed specifications. This began in December 2008 with a number of working documents, and the working group just about a week ago issued the second draft standard 621-page document that is moving toward completion of the final draft specification. Now, the WiMAX Forum has historically developed a set of specifications that make use of the 802.16 air interface specs at layer 1 and layer 2 to define a system-wide end-to-end WiMAX release. And the forum will be doing the same thing in the case of the 802.16m. The forum and the IEEE have worked together closely in many areas, including the ITU activity. This chart is illustrating a sense of what the WiMAX Forum release looks like in terms of what the forum is currently calling a 6-stage process. What you can see here is on the top box, which is the blue one, shows the air interface specs. And it's showing from left to right stage 1, 2, 3, 4, and 5 in the blue. And then off to the right, you'll see this certification process, which we call stage 6. So the forum is really unique in supporting the entire process, not only the development of specifications, but the delivery of certified products. And it's really going far beyond the process of completing the books, but really supporting the introduction of taking the products virtually into the marketplace. This really makes for a much more efficient system than you have when you just develop 3 stages of spec and toss them over the wall and expect them to be implemented and certified. So the forum has its own set of air interface specifications. These are significantly based on the IEEE 802.16 standards, but turned into a very detailed set of conformance statements and test procedures, certification procedures. The box in the center, which is perhaps a bit orangish on your screen, is showing the network specifications. These are the higher layer specs above layer 2 that are uniquely defined by the WiMAX forum, a very comprehensive set of specifications that represent the network at layer 3 and interfaces to the IP layer. And the forum also has the row on the bottom shows you the roaming specs. And as you've heard some announcements today, some of the initial successes of the WiMAX forum roaming program have been discussed today and are being demonstrated over at the exhibition across the way this week. The IEEE and the WiMAX forum are both members of the ITUR as sector members, as international organizations. And the IEEE has been actively engaged with ITU for a number of years, so that several existing recommendations do point to the ITU standards. But the highest profile of all the ITU standards are the ones that fall under the designation of IMT for International Mobile Telecommunications. This is overseen by ITUR Study Group 5 and its Working Party 5D. Beginning in 1998, the IMT 2000 specification has included officially 5 evolving terrestrial radio interfaces, but the key ones are under the category of 3GPP and 3GPP2, WCDMA and CDMA 2000. The first significant change to the IMT 2000 specification in a decade happened in 2007 when the ITU agreed to add a new radio interface called OFDMA TDD WMAN, which is based on the IEEE 802.16 and WiMAX Forum Release 1. This year, the Working Party 5D approved a revision to the IMT 2000 spec, which includes the FDD as well as the TDD components of the 802.16 standard. Several years ago, perhaps about 5 years ago, I would say, the ITU began to envision a future beyond IMT 2000, and eventually it was given the name IMT Advanced. It was to cover mobile systems that include new capabilities beyond IMT 2000, fixed services that are fixed and mobile, increasingly packet-based, supporting up to low to high mobility applications and a wide range of data rates, and wide ranges of services and platforms, and significant improvements in performance and quality of service. This work was formalized in terms of a number of specific set of requirements that are very challenging. And eventually a schedule was developed to develop the IMT Advanced process. We are currently at the last meeting of 2009 where it says number 6, and the meeting number 6 was concluded last week. And that was the end of the step 3, which is the submission of candidate proposals for IMT Advanced. The deadline was October 7th, and actually formally six proposals were received at this meeting for IMT Advanced. However, these were grouped into two technologies. One was the IEEE technology with 3 proposals, and the other was the 3GPP technology, also with 3 proposals. They were all considered reviewed and considered complete, and the next step is to initiate the external evaluation of these proposals to have them reviewed by independent external evaluation groups. Now, to help explain the idea of the 3 proposals, or the 6 proposals for 2 technologies, this slide lists the 3 proposals related to IEEE technology. IEEE's contribution was called Submission of a Candidate IMT Advanced, RIT, based on IEEE 802.16. RIT is the name for Radio Interface Technology. Another proposal came from the administration of Japan, and it was called a proposal for IMT Advanced based on IEEE 802.16. And the third one came from TTA, which is the Standards Association in Korea, and it was called Submission of a Candidate Technology based on IEEE 802.16. And these were reviewed by the working party, which concluded that all 3 technology proposals were identical, and they would collectively be considered the IEEE proposal. The WIMAX Forum helped to organize, decided after it made the decision to endorse this proposal, it put together a contribution to ITU endorsing the proposal, and it asked around some companies to see if they were interested in also endorsing. And it turned out that an even 50 companies agreed to co-sign the contribution. And if you take a look at it, you'll see that there are really a very broad array of ecosystem participants from many countries, many different parts of the ecosystem, and operators from startup operators to successful 2G and 3G proponents and operators, many of whom are here in the room with us today. WIMAX Forum is engaged in development of Release 2 specifications in parallel with 802.16m and IMT Advanced. The WIMAX Release 2 networks and devices will remain backward compatible. They will offer improved VoIP capacity, spectral efficiency, latency, handover speed, cell range, and coverage, and will support wider bandwidth in both TDD and FDD. The WIMAX Forum expects to see WIMAX Release 2 available commercially in the 2011 to 2012 timeframe. The proposal that IEEE made actually documented its applicability to 4 of what ITU called test environments, and these are specific sets of requirements grouped into 4 applications, which are designated as indoor hotspot, urban microcell, urban macrocell, and rural macrocell, otherwise known as a high-speed environment. So the ITU decided that there were really at least four different ways of looking at the applications of IMT Advanced, and each one had its own unique challenges. The indoor hotspot was looking at data rates up to 1 gigabit per second and required these kind of very high speed rates for a low speed, like pedestrian rate users. The urban macrocell moved to a microcell and macrocell were different size cells for urban deployments in different frequency bands, and then the rural macrocell was the larger cells with the high-speed requirements embedded, up to 350 kilometers per hour. And proposals were required to satisfy at least one of the 4 test environments. Now, the IEEE proposal documented that it could technically satisfy all 4 of the test environments in both TDD and FDD. Now, these charts may be difficult for you to read, but these are the charts that we provided, the IEEE provided as part of its proposal to document its performance. And this laser won't work, but the one of the requirements is for cell spectral efficiency, which is requires a detailed full simulation of the system, including cell interference and a series of mobile stations from nearby the base station to greater distances. If you could look at this chart in detail, and I believe it'll be made available to you in the PowerPoints and the slides later on from the organizers. For instance, if you look at the indoor system, the ITU requires a overall cell spectral efficiency of at least 3 bits per second per hertz, and the IEEE proposal documents that the performance was virtually 7 bits per second per hertz in that environment. In some cases, for instance, in the rural case of the rural macro cell, the IEEE proposal documents performance that's almost 3 times the requirement. So in some cases, the 16M proposal is a bit better than the IMT Advanced. In some cases, it's up to 3 or even more than 3 times as high as the requirement. So this chart shows the results for both TDD and FDD and both downlink and uplink. Additional requirements were provided for cell edge user spectral efficiency, which takes a user out at the edge of a cell and looks at kind of a worst case requirement. There were some requirements for mobility, and this shows 4 different mobility requirements from 10 kilometers per hour down to the rural high speed, which was requiring up to 350 kilometers per hour, and showing that the achieved spectral efficiency is high. For instance, if you look at the last row of the at the high speed, the ITU required 0.25 bits per second per hertz, and the 802.16m is achieving 1.7 in line of sight and 1.2 over 1.2 in the non-line of sight. Now, these numbers were developed by IEEE from contributions that came into the working group from companies that had done detailed simulations. And in fact, many contributions were made to the working group. So these results were averaged over inputs from a number of different independent evaluations from different companies. And the numbers were basically in line with each other, but the averages were submitted. The VoIP capacity is very, very significantly, even the ITUR numbers are very challenging. They required, for instance, in the high-speed case, 30 users per sector per megahertz, and the 802.16m proposal is showing about 3 times that capacity, 90, even in the case of the high speed. The challenging numbers that were put together for ITU for peak spectral efficiency are 15 bits per second per hertz in the downlink, and the IEEE proposal exceeds that number in both TDD and FDD case from between around 17 to around 18. And you can think about the numbers. If you had a 20 megahertz channel and you had 15 bits per second per hertz, you're talking about a 300 megabits per second peak rate, and that's on the downlink, and that's the ITUR requirement, and this is exceeded by the proposal. So I just put together one conservative example. It's really very conservative, but it's taken from some of the numbers. It's, again, a very rigorous full simulation accounting for all the interference. And this is a very limited scenario where you would have a single 20 megahertz TDD channel available system-wide. And you built a system based on 3 sector base stations with the reuse 1. Using 4x2 MIMO, which is really not a challenging situation, a really very kind of a mundane, practical example. And in this case, the 16M system would support 120 megabit per second downlink and 60 megabit per second uplink per cell site simultaneously. Now, there are lots of ways to scale this number up, and if additional spectrum resources available or additional antenna resources are available, or you want to redeploy your system, redesign your cells for higher capacity, that's easy to do. Peak data rates, you can say hundreds of megabits per second. It depends on how you want to design it. And if you want to design an indoor system with a gigabit per second, no problem. The technology is there. The latency requirements were challenging for IMT Advanced, and I won't go into them, but the proposal met or exceeded all of those latency and handover interruption requirements. The ITU, over the next 8 months, will be running an evaluation process with external evaluation groups that will be developing the independent evaluations of the proposals. And there are 14 of these groups that are listed here. The WiMAX Forum has set up its own evaluation group, and if you'd like to meet the chair of the group, he's here at the meeting. I talked to him this morning. It's Yikong Fu from MediaTek, and he'll be able to talk to you more about that activity. The IEEE 802.16 working group is going to be engaged with these evaluation groups to help to interact with them, and really wants to take advantage of their expertise in their evaluation so that we can bring that knowledge into the working group to help refine the stage 3 specification as necessary. The 802.16 working group has arranged a meeting for these IMT Advanced evaluation groups next January to work with them, and I believe that it's my understanding from discussing with most of the external evaluation groups that they will be sending representatives to that meeting. So I'd like to conclude by simply reminding you that IEEE, with very broad support, both inside the working group and international support and the corporate ecosystem and the WiMAX Forum, has brought forward a proposal developed over, so far, 3 years to update 802.16m and documenting that it meets all 4 of the ITU test environments. And the WiMAX Forum is quickly going to bring this technology to the market as WiMAX Release 2 with full backward compatibility, offering future-proof technology for the next decade. This is technology is going to evolve and roll out, but I'm confident that the Forum technology is going to be the first one to market with IMT Advanced and is going to be quickly rolled out because of its backward compatibility and because of the support of the ecosystem, including those of you here in the audience today. It's going to be the first one to market to bring this new technology to market that supports the needs of the next decade. Thank you.
Thank you, Mr. Burke. Thank you. Now, ladies and gentlemen, we'll proceed with a lunch break.